Hello, leader. Can you? Okay, okay, okay. Thank you, thank you.
Can everyone see my screen?
Yes, ma, I can see from my end.
Any other person?
Yes, ma'am, I can see your screen.
All right. Whew. So let's get started. So today we're going to be talking about cloud threats identification and attack simulation. And but before we start, I want to ask, how's the project going so far? Hello, how's the project going so far?
And good evening, ma'am.
Good evening. How are you?
I'm fine, thank you.
All right.
So far we've been, well, my teammates and we just finished the meeting actually for the class. We've been collaborating. So far it's been good. It's been, it's a fair project, honestly. It's not something beyond us. So far I would say it's been good on my end.
Right. Fair enough, actually. Fair enough. Yeah, so let's get started. So last week we learned how to secure cloud infrastructure. That's building defenses, configuring encryption, and setting up monitoring. So this week we're flipping the script. We're going to think like attackers to understand how cloud systems get compromised. So here's the hacker's mindset. This might sound, should I say, counterintuitive, but to be a good defender, you need to think like an attacker. So professional security teams have what we call red teams, and these are ethical hackers whose entire job is to try to break into their own company systems. Why? Because finding vulnerabilities yourself is better than waiting for criminals to find them. So what we're going to cover today, or what we will try to cover, depending on time, is to understand what cloud threats are and where they come from, the most common attack vectors in cloud environments, and how to use threat modeling to identify weaknesses before deployment, how to safely simulate attacks to test your defenses, and how to use the Microsoft Threat Modeling tool, a free industry standard tool. Although now you can also use AI to scale threat modeling, but that has to be done safely. In fact, in most cases, you have to first consult your stakeholders if they can use, if they want you to use, or if they would approve you using AI to scale threat modeling or to make it faster. So before we go further, everything we discussed today is for ethical, authorized security testing only. You only test systems you own or have explicit written permissions to test. Because attacking someone else's systems, even to help them, is illegal. It's computer fraud, and people go to prison for it. So please, our goal is to make our own systems more secure, but not to hack others. So, introduction to cloud threat identification. What is threat identification? Threat identification is the process of finding potential security risk before they're exploited. You know, it's like doing a home security assessment before you move in. So rather than after you've been robbed. So why is cloud different, or why cloud is different? Cloud environments, they are dynamic and they are highly scalable. So well, that's great for business actually, but it also means that new resources spin up constantly. Like maybe every new EC2 instance is a potential attack surface. Configuration changes happen frequently, means there are more opportunities for mistakes. Then multiple teams manage different parts, that's coordination gaps. Then shared infrastructure is infrastructure. So this means that you're on the same or you are on the same physical hardware as other customers. So the cost of missing threats, let me give you some context, maybe with real numbers. So Capital One breach in 2019, 100 million customer records stolen, social security numbers, bank accounts, credit applications. The vulnerability is that a misconfigured web application firewall cost was what I think about $190 million in fines and settlements, plus permanent reputation damage. Another example would be Uber breach 2016, 57 million customers, I think, yeah, 57 million customers and drivers affected. Attackers found hard-coded AWS credentials in the GitHub repository. So Uber had to pay hackers $100,000 to delete the data and keep quiet. When it was discovered later, I think about $148 million settlement, the CEO resigned. So the pattern here is that these were not even like sophisticated nation state attacks with zero-day exploits. No syndicate is trying to like attack them. It is, or they were just simple misconfigurations and basic security mistakes. Public S3 buckets, hard-coded credentials, overly permissive IAM roles, and unpatched systems. So the key points on this in this slide is that ethical hacking is a real job. This is absolutely true. Let me tell you about red teaming. Large organizations like banks, tech companies, government agencies, they hire people to attack them. These red teams or penetration testers get paid like I think about $6 to try to break into systems, social engineer employees, find vulnerabilities before criminals do, document weaknesses, and to help fix security gaps. So this is a legitimate, well-paying career path. And certifications like CEH, Certified Ethical Hacker, OSCP, Offensive Security Certified Professional, and GPEN, they are all highly valued. So another point here is that small misconfigurations can expose millions. So this can be overstated. Let me give another specific example. I think single checkbox. So imagine that you're setting up an S3 bucket for customer data and you go through all the steps. You enable encryption, you set up login, but you forget to check one box. And that's like block all public access. So that one checkbox just exposed like 10 million customer records to the internet. Anyone with a bucket URL can download everything, no hacking required. Look at that. You will think, oh, maybe somebody is going to hack up someday. Somebody is going to do this, infiltrate into our systems. And it's actually just one simple misconfiguration that will just, get your data out there. Another example is copy-paste error. A developer copies an IAM policy from Stack Overflow. People do this a lot. You can do this if you're testing. Maybe if you're learning something, for example, if you're just learning something for the first time and you're like probably lost and you try to like copy, maybe you check Stack Overflow or you check maybe Reddit or whatever, wherever you get your help from, because you're testing, not like you're actually like working, you're not working on your company's actual system. So the copy paste error comes from where maybe a developer copies an IAM policy from Stack Overflow and the example policy has resource, meaning all resources. Like you know that in policy there's this sign, let me just say sign. I think asterisk in quotes means everything, like all resources. So you're not like identifying any particular resource. You're not saying institute, you're not saying S3. So if you say maybe allow so to then under resources, you just put that asterisk in quotes. It means that you're saying all resources. So the policy copied has that, and the developer does not change it. Now that role has access to everything in the AWS account, and if that role is compromised, the attacker owns your entire cloud environment. So the takeaway here is that small mistakes have massive consequences in the cloud. And that's why threat identification is so important. We need to find these mistakes before attackers do. Now, what is a cloud threat? A cloud threat is any risk that can compromise the confidentiality, the integrity, or availability of cloud systems. So let's break that down. These three words, or those three words, are very, very, very important. Confidentiality: can unauthorized people see your data? Examples again will be public S3 bucket leaking customer records, that's confidentiality breach. Stolen API keys, allowing access to databases. Misconfigured IAM role, exposing financial data. Now, for integrity, can someone modify your data or systems without authorization? Examples would be attacker modifies price data in your database, that's e-commerce fraud. Malware changes application code in your EC2 instance, or someone deletes your S3 objects. Now, availability will be, can users access your systems when they need to? Examples: DDoS attacks, crashes your web servers, ransomware encrypts your databases, accidental deletion of critical infrastructure. So now, 5 sources of threats. Number 1 is human error, misconfiguration. This is the number 1 cause of cloud breaches, not hackers. It's literally always mistakes. So real world example would be, I think, Accenture in 2017. A consultant misconfigured an S3 bucket while setting up a data analytics project. The result was 137 gigabytes of data exposed, including API keys and credentials for their cloud infrastructure, certificates and access keys, decryption keys. So the data was publicly accessible for months before being discovered. So some other common misconfigurations will be leaving your SSH open to anywhere from the internet, not enabling encryption on S3 buckets, using default passwords, not enabling MFA on root accounts, overly broad IAM policies, not enabling CloudTrail login, public snapshots of EBS volumes or RDS databases. So here's the scary part. They are all of this misconfigurations are all preventable. Every single one of this is a checkbox or configuration option that someone missed or chose wrong. So another one is weak identity and access controls. That's another type of cloud threat. So if IAM is misconfigured, attackers can gain access even with strong perimeter defenses. A scenario would be overprivileged intern, having an intern that is overprivileged. So a company you have a company and you hire an intern for the summer. IT creates an IAM user for them. Easiest approach, yeah. You attach administrator access policy. Intern can do their job, no problems. But the issue is that intern now has the same access as CEO. Yeah, admin access policy is like the easiest because you just have to like probably check a box. You don't have to go through the stress of picking policies for them, picking. I remember during the IAM class, I said, you would think, if I tell you that one of the issues that a lot of companies have with IAM policies, balancing convenience with security. They want to be convenient and they also want to be secure, which is not possible. You have to go through that stress. That's just the thing. So like this person in this scenario just picks administrator access policy because yeah, they'll be able to do their job. They won't have to come to you and say, oh, please, I want to have access to something. You don't want to go through the stress of refining their permissions. You don't want to go through the reviewing their permissions. So you just give them that admin access policy at once. So now they have the same access as the CEO. They can delete production databases. They can terminate all EC2 instances. They can disable security login. They can even create new admin users. And if the intern's laptop gets stolen at a coffee shop, the laptop had AWS CLI credentials saved. Attacker now has a full admin access to your entire AWS account. So a better approach to that would be least privilege. The intern only needs to probably read from S3 and write logs to CloudWatch. Give them only those permissions. If compromised, damage is contained because they don't have access to like the general stuff, like the whole picture here. So another one will be software vulnerabilities. See, unpatched systems have known vulnerabilities that attackers can exploit. Another example of this would be Equifax story. Equifax breach in 2017, 147 million records stolen. The vulnerability was Apache Struts, that's a Java web framework, had a known security flaw. The patch was available for 2 months before the attack. They just didn't install it. Why does this matter in cloud? In cloud, you are responsible for patching your EC2 instances, your containers, your applications. AWS patches the underlying infrastructure, your hypervisor, your physical hardware. But the OS and software, that's on you. You go back to your shared responsibility model. You see, what I love about cybersecurity or any field is that the basics never stop showing up. They just never stop showing, because when you understand the shared responsibility model, nobody tells you. Like, you don't need to even, like, you just know what you're supposed to do. That's just it. So one of the solutions that could have, solved this is automation. This is where automation helps. AWS System Manager, Patch Manager, it can automatically patch all instances. Container image scanning, find vulnerabilities before deployment. Dependency scanning, alert when a library has a known CVE. I think you can literally do that with GitHub. If your code is in GitHub, or if you've used GitHub before, you can set up dependable bots that will alert you when you have dependency errors, or sorry, when your dependencies probably they're out of date or something like that. Then another one will be malicious insiders. Not all threats come from outside. Insiders can be threats too. And I think recently I um I think some of the, should I say, one of the cybersecurity professionals that I really, really like follow, like when I mean follow, like I literally that was where I learned cybersecurity. She created the foundation where I learned cybersecurity from. So she was saying it that I think during she has this AI podcast or something. She also has like this AI magazine. So she was saying in one of our speaking sessions, I can't remember, but she was saying that a lot of people keep talking about insider threats, but AI is already like the beginning of your insider threat. Like, everybody's doing, it used to be bring your own device, BYOD, but it's now bring your own AI. If I'm working, you never know how many AI software or how many AI agents I have, or how many AI applications I use that I feed your company's data with. You can't check my device. Like, it used to be, oh, when people bring their devices to work, they're like, oh, the company's at risk because you don't know, maybe they've been tailed from outside, and when they're using blah blah blah. But now there's additional scare, like there's an additional jump scare. Bring your own AI. People have like about 30 to 40, 50 to 70. Like, they download as it comes every day, Open Club, Notebook, CloudBot, they just have everything on their laptop. Now that you can even give AI full access to your computer, can send messages, can read your email, can do literally anything that you want. So I actually agree with her when she said it is now like bring your own AI. She had talked about bring your own AI like years back. But now she's not saying that. People used to say instead that threat is the problem. Insider threat is the problem. But now people, even your AI that you're using in your company that you're deploying, is also an insider threat. So that's just that's that. So the types of insider threat that we have now, we even had AI to it, but let's start from like the disgruntled employee. When an employee gets fired and still has access for 2 days during onboarding, person can download customer database, can delete production data, can create a backdoor account. As well as we are in my startup, if you are leaving, if you're, I don't know, if you're leaving, maybe you want to leave or you're asked to leave or whatever, whichever it is, the first thing I do is to delete your mail. Yeah, because everybody has like an official mail, so delete your mail, because you can use the mail to post as us when you're literally not working with us again. Delete your mail, delete your access to anything that you've been given access to. So with that, we that are doing that right now. So imagine when we literally get bigger, things like that never be missed. so that's it. Yeah. So if we have a negligent employee, developer thinks that I'll just upload this database back up to my personal Dropbox so I can work on it actually. But his Dropbox account can get compromised, and when it gets compromised, customer data is leaked. The last one here would be like we're just talking about malicious insiders. So Another one will be the compromised account. Employee clicks phishing link, attacker gets their AWS credentials, technically an insider's credentials, but used by an outsider. Recently, somebody sent me something on TikTok, obviously a scammer, saying that he's leaving this world and he's leaving money behind for me. Then he sent the website, gave me username and password. Said, okay, at least somebody cares about me. Nobody cares about me to leave money behind for me. Do you people want? Maybe I should share the log so that we can over. He said he left a lot of money for me. So attackers, scammers and attackers are looking for ways to like get people to click on the wrong link. So if it's somebody who is not really cyber aware, or I don't know, you can say, oh, people will not do it, or because it probably looks fake or something. But I'm telling you that people would actually click on that link. So yeah, don't be surprised that if it were another person, person would actually go to the website to check if there's money there, and it's most likely phishing link to get access to your device or get access to your sensitive information. So that's it. So mitigation to something like that, mitigation to a compromised account will be least privilege, not just compromised accounts, malicious insiders generally, least privilege. You can't steal what you can't access. Separation of duties, no single person should have all access. Logging and monitoring, detect unusual behavior, automated onboarding, revoke access. I think one of the things I would do is that automation. Once you say you are leaving, like I just click one thing and you just see that by like the next minute, you met you drop a resignation letter like this, the next minute you can't even have you just see that you were even waiting for me to leave. No, we're not waiting for you to leave, but we are prepared in advance that you might be a bad egg. So let us just so that kind of thing, yeah. So another one will be regular access reviews. When somebody's no longer using something, or when you gave them access probably 2 weeks ago and they're done with it, please revoke or remove unused permissions. The last one will be external attackers, the hackers. Can you see all the types of threats that we had to mention before we got to the people that a lot of people scream about? It's just like saying devil is a bad person, devil is this, devil is that. And you see people actually doing things like they are doing things that looks like as if they are putting themselves out there, or they are purposely doing things that will make people say, it's the devil's fault. So sometimes the devil is on its own and it's just human beings that are just, probably doing things like that. Also, look at all the things that we had to mention before we got to the, talk of the devil. So external attackers, sometimes it's not even the external attacker. Sometimes even somebody who is even professional, it's just you that you left your stuff open, and somebody who happens to be lucky, who is looking for something to probably grab, saw it and felt, oh, this is good for me. So yeah. So this is what most people think of when they hear cyber threats. Hackers from the outside have been hacked. Or they say it could be, oh, I can't be hacked because I don't have money, I'm not popular. What makes you think they care about you? It's what you have access to. You work in Dangote and you probably, even if you drive Toyota Camry, or you work in Dangote, you probably have access to something. So yeah, that's it. Nobody really cares about you. It is what you have access to. You have an official email account, most likely you're in admin. You're not working in refinery, or you're not working as a laborer or something. You have probably have an official email account. Or even store managers these days, they know that at least they have access to something. They have there's an hierarchy of access, even if it is physical, because physical security is also part of cyber security. I know that you have access to where they store so. So things like that, we should not say, oh, I'm not popular, nobody would want to attack me. So types of external attacks, credential theft, phishing for AWS credentials, finding API keys in GitHub repositories, brute force weak passwords, buying stolen credentials on the dark web. Exploitation will be SQL injection against web apps, exploiting unpatched vulnerabilities, and server-side request forgery to access EC2 metadata. Then we also have port scanning to find open services, checking for public S3 buckets, enumerating IAM users and roles, social engineering to gather information. So most of the times, they sit somewhere and they're just looking for one scapegoat to fall into their trap. That's just it. They're just looking, somebody will click on something. Somebody will open a port. Somebody will give overly permissive role. I will be able to get somebody's trust through social engineering. They know that humans are greedy. They know that eventually somebody will fall into their trap. Do you get it? So that's just it. So the reality is that external attackers are persistent and patient. They are very, 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 very patient. That's why when APTs happen, that's advanced persistent threat, once they're able to enter, before you can send them out, because they've been waiting. They've been waiting for that loophole. They've been waiting for you to have that cracked wall for them to get in. And they'll make sure they maintain. They might not even attack you for a very long time, but they know they have access. They are watching you. They know they have this. The day they will attack. So that's just, so they will spend weeks or months mapping your infrastructure, finding the weakest entry point, moving laterally once inside, establishing persistence. Remember, advanced persistent threat. Exfiltrating data slowly to avoid detection. That's why a lot of times APTs goes undetected because they maintain if I want to maintain access in somebody's system, I won't do things that will make the person know if I am there. Network issue today, network issue tomorrow, like that. Like you keep thinking it's network issue. Oh, our technical team will fix it. I'll let you fix it. We'll be able to fix it. Another time I'll eat you again. Oh, sorry, we have currently percent downtime. That's what you keep telling your customers. So that's how it works. So the key insight is that effective threat identification requires understanding both technical weakness and operational risk. Technical weaknesses: unpatched software, misconfigured security groups, weak encryption, open ports, public resources. Operational risk: lack of training, when employees don't know security best practices, no change management, unauthorized changes, poor access governance, stale accounts, over-provisioned access, no incident response plan. You don't even know what to do when you get attacked. Insufficient monitoring, you can't detect breaches. So you need to address both. You need to have perfect technical control. See, perfect technical controls won't help if your employees are clicking phishing links, no matter what you do. If that one person will still, like the message I said I got, in these trying times, somebody's leaving money behind for me. And the person gave me username, the person actually even put the name of like the website, the link to the website where I'll be able to like input the username, password for me to be able to get the money left behind for me in these trying times. You think people won't click on it, or please think again. So yeah, before I move to the next slide, do we have any questions?
Yeah, I have a question.
Oh, okay, go ahead.
Okay, so I was reading a story, I think last year, about some guys that got hold of an API key for MTN Nigeria, and they stole some like 9 billion of data. So I'm just thinking to myself when you spoke about hard-coded credentials. So the first question would be, if I make my GitHub repo private, I know public, anybody can access it.
Yeah, sure.
Does this still mean I can be attacked? That's the first question. The second one is that I know definitely like the work we are doing, that's our projects. For my group, you said we should use like a Lambda function. I know I've not done anything on this, but I'm just thinking ahead that definitely for us to do some things, you might need to reference the bucket and the KMS key. So from what you just said in class, now that's not right. So how do we do that? Because definitely if you have a
Are you
code,
asking for expo?
no, I'm not asking for expo. I'm asking for it. So I'm just looking at those. I'm looking at those scenarios
Okay.
like you spoke about Capital One, the Uber breach. No,
Mm.
most times people talk about these breaches. Okay, this was wrong, but what's the right thing to do? What's the correction exactly? Most times you don't hear about it. So you said that an API key should not be hard coded. So what's the right practice? Is it to rotate it or something like that?
Yes, now. Did we do encryption? Let's even start from there.
Yes, we
Did you
did
do
the encryption,
encryption?
But also
Mm-hmm.
looking at that code part, because I know on
Mm-hmm.
AWS, there's a place you see environment variables. So how
Okay.
does it apply when you have a code and you want to reference like an AWS service? And definitely there'll be an ARN you want to reference. Probably you want to attach this resource to only this permission or role or things like that. So what's the right thing to do so you not
Your
upload it?
workflow can reference them without even exposing the actual value. If you use
Okay.
GitHub secret,
Okay.
yeah,
Okay.
GitHub
Without
secret can
GitHub, if we are just doing it on AWS front now.
your local developer .m file now. You can store it locally.
Okay. Okay.
Do you get?
Yeah.
So that .m file, yeah, you just save it to your Git ignore. You know, there are some files that you don't want to, when you're pushing
Yeah.
your code, there's some files that you don't want to push, that you put under Git ignore. So you just push that .m file to Git ignore. So it never gets committed.
So if you are deploying, probably you are pushing a code through a pipeline, are there like tools to scan for those things?
So what?
I say if you are pushing your code, probably you are deploying on a pipeline or something or from GitHub
Mm,
to production. So are there like
mm,
tools you can install or extension you can install on GitHub to scan for those things and to flag them?
okay. Well, you can I think Python, there's this particular one. Is it Python.env or what? There's a tool, Python.env or .env for Node.js. Oh, I can't remember. Don't worry, I'll ask for you. Me, I'm not a
Okay.
software engineer.
Okay.
But don't you want to use GitHub secrets?
I want to, but yeah, like most times people can be saying they want to deploy on Kubernetes. So
Mm,
definitely, or if you have an image file and you want to protect that image file, how do you go about it? Then also I was thinking on that part of people, an API key will sit within an infrastructure is protected. So how did those guys get hold of the API key and steal MTN's data and subscription? And they even went to court. There's no tangible evidence to hold them by. And those guys went scot-free. And from what you've explained to us about compliance, MTN did not, no compliance body held them responsible or things like that. So I'm
if you
just like
add code,
thinking,
if you had code your keys, know that, like I say, attackers take time. They can spend months, they can take their time to scan platforms for exposed secrets. So they can use automated bots, they can use search queries. Just like the way you are looking maybe in your CloudWatch, you're trying to like query particular thing. They can also use query to search out exposed secrets. Like they'll search out maybe API key, AWS secret access, something like that. Even if you delete credentials, they can still recover it from Git history.
hmm, okay. Or will it mean that probably when the data is in transit, it was not even encrypted and the API key was exposed?
Maybe.
Okay.
Were we able to answer your question? At least have
Yeah, I'm just like maybe I'll still ask again, but I'm just thinking loud.
you
It's
still ask
fine.
what?
I say I'm just thinking probably when I get to the part of that project, I don't really want to this we've not really learned about Lambda in class really. So it's like I don't know, it's kind of tricky
Mm,
for me. And so that's what I was asking.
yeah, I get you. You can always make use of, if you want to store your secret or you want to store keys or anything, just use AWS Secret Manager.
I also noticed that even when you want to rotate the key, you also need to write like a Lambda function too. So
Have you started? You started your project?
no, I was trying to do something personal with my friend was doing like a project, something linked to secrets and everything. So
Okay.
we wanted to rotate the key for a particular number of like 90 days or thereabouts.
and he was telling us to write a Lambda function for it. And we're trying to say, okay, we don't understand this Lambda function thing. Let's just rotate the key normally, and we could not even get anything on the UI console to even do that. So I was like, how does this thing really work?
Okay, yeah. Can you tell me the project? What was the project? Can you read it out?
So the project was, he has a secret. He like created a dummy API key.
Okay.
So what he wants to do is that
Okay, this is not
anybody,
your project. Is this your project, like for the class?
no, it's not my project. This is like something somebody was asking me during the week.
Oh, somebody was asking Paul. Bye bye.
No, it's something we can learn from, just like putting it across to you, like you're teaching
Yeah,
us.
of
So,
course, of course, of course, of course.
so this is
I
what he's
was
trying
thinking
to
it
do.
was your project and you were having issues.
No, but I'm still going to ask for my project, sha.
You are still going to, yeah, maybe you should keep the energy for your own project.
No, I'll keep that energy. I'm building it up. So this is what he wants to do. So they like developers that access keys anyhow. So what he wants to do is that anybody that accesses a particular key in a particular period, you should be able to get like a trigger, an SNS trigger on alarm from
Okay.
CloudWatch, listing the person's IP that access that key, what time and the likes of it, and the probably the IAM role or the IAM name or something like that that has it. So what he was trying to do is that people access that key all the time, but he also wants to rotate the key. So even if the key gets compromised, they will not have the current key that was there. Like the value should be changing. So that's like what he was trying to do.
Oh, I get you. I get you. Can we talk about this after class?
Okay.
Okay. Oh my God, where was I? Yeah, so common cloud security threats. So let's get specific. These are the most frequent cloud threats we see in the real world. Misconfigured storage. We said this a whole lot of times. Overly permissive IAM rules, credential theft, unpatched systems, denial of service. We've literally done everything. So some of these things, how do they even happen? Let's look at this scenario, default setting trap. So developers create an S3 bucket quickly for testing. They don't realize that by default, in older AWS accounts, buckets could be made public by default, like in older AWS accounts. So uploads production data for quick testing, forgets to change settings back. Bucket is now public, and data is indexed by search engines. Another one will be permissions creep. The bucket starts private. Marketing team needs to share some files. IT adds a bucket policy allowing public read for a specific folder. Policy probably has a typo, which says resource ARN AWS S3 bucket instead of resource ARN AWS S3 bucket public. Then now that means that the entire bucket is now public. So another scenario would be ACL confusion. S3 has two ways to control access. One, bucket policies and ACLs, that's access control list. They can conflict. Bucket policy says private, but ACL says public read. What would win would be the least restrictive. So this is why AWS added block public access settings. They override both policies and ACLs. Oh, God. Another one would be overly permissive IAM rules. The problem is, again, IAM rules with excessive access rights, more permissions than necessary. Why it happens? The convenience, like I said, the convenience factor. Developer needs S3 access for the application. They Google AWS S3 policy, they copy it, they paste it, works great. Obviously, a lot of them would actually work. But the problem is that it gives access to all S3 actions on all buckets in the entire AWS account. Troubleshooting escalation. App is not working. Developer, maybe it's permissions. quick fix, add more permissions, still not working, add even more permissions, eventually giving the resource full admin access. The application works, ship it to production. Now, if that role is compromised, attacker has full admin access. There are like so many. I don't know if you guys actually do this assignment I gave you guys one time. I think you should research for threats, like um yeah, maybe case studies of threats, what caused it, what year. I think Paul said he was reading one about MTN, right? Paul.
Yes, yes, yes.
Mm-hmm. So if we read more case studies like that, we'll be able to understand, especially for cloud security or maybe general threats, literally. You'll be able to understand, okay, how did this even happen? What did they leave open? Like now, Paul is being curious how they were able to get the hard coded keys and everything, and so that's how you get curious. That's how you challenge, your critical thinking and all of that. So when you want to probably do projects like this, or when you're actually working in an organization, these things can give you insights to how it is. Trying to see if we can. I want us to manage time because I want us to do that use that Microsoft threat modeling. So trying to be like this is this shared responsibility model. I'm going to allow you guys to explain to me because we've done it 1,000 times. So please explain shared responsibility model to me. Oh. I'm waiting. Oh. Hello. Hello, everybody. Do you want ice cream? Oh yeah, you guys should explain shared responsibility model to me. Hot.
Okay, so I think shared responsibility model, the way AWS says is that they are responsible for what happens inside the cloud. That's AWS themselves. Then the customer is responsible for what happens from off the cloud. So, for example, if I have a particular software as a service, I'm responsible for the data that's in that service. Then AWS or Azure, any cloud provider, is responsible for how probably the servers or that things function. Or if it's platform as a service, they are not responsible for or for example, if it's a Lambda service, I'm not responsible for provisioning the servers or anything like that. I'm only responsible for my code and things I put there. So shared responsibility model simply means that because people have this idea, if it's cloud, the cloud provider is responsible, but it's not true. If I have infrastructure as a service, that response speaks to my compute service, virtual machine, storage. I'm responsible for encrypting. I'm responsible for patching. I'm responsible for attaching storage disk or the likes of it. AWS will not say they're responsible for creating subnets for me or creating internet gateway, how I would expose things to the public. So it just tells you that the cloud model does not hand over everything to the cloud provider. I also have my own part to play, and also the cloud provider has their own parts to play. Then also, if I'm setting up things like deploying an application, if I deploy the application in a particular region, if that region goes down, is basically my responsibility because I had the option of deploying that application in multiple regions. You're also responsible for things like costs. Different regions don't have the same cost, so basically you need to be knowledgeable about where you're deploying. So, for example, now us that are in Nigeria, we might think that the closest data center will be an African country. But if you Google and check very well, you'll be surprised to see that a particular data center in Europe is more cheaper than a data center in what they call it, South Africa. And I think that's where I saw that was when I was checking something on Azure. I was trying to deploy a particular VM. I discovered that the VM is even more expensive in South Africa And South
So
Africa is meant to be like home, but it's not like that. So that's what I think shared
that's what you
responsibility
think.
means.
That's what you don't say. That's what you think. Don't say that's what
That's
you
what
think.
I know from
Eh,
because there are documentations supporting that.
hey, I want you to be confident. I want you to be
Yeah.
confident. You actually explained it very well. I like it. You start for yourself. Ah, can't hear any sound though. Are you clapping? Okay, so I think Paul has helped us out because if by this stage you don't understand shared responsibility model, let me just come and fight you myself. Because when you are doing your project, these are some of the things, these are some of like the core principles you have to like understand or remember that what am I responsible for? Who's responsible for this? What should I do? And all of that. So please let's move to the next slide, of course. Why we are here. Introduction to threat modeling. What is threat modeling? Threat modeling is a structured approach to identify potential security threats before they occur. It's like doing a security risk assessment during the design phase, not after deployment. So let's use the fire drill analogy. Think of threat modeling like planning fire exits before you build a building and not after it has been burned out, it has been burned down. So you ask, where could fire start? How would it spread? How do people get out safely? Where do we put fire extinguishers, alarms, and sprinklers? Then you design the building with these answers in mind. We also call security by design. The same for cloud security. Threat modeling asks questions like, what are we protecting? You're protecting the assets. What could go wrong? The threat. How can we prevent it? Controls. How will we respond? Incident response. So let's look at these 4 questions. Question 1, what are we protecting? The first thing is to identify assets. You need to know what you have and what's valuable. Examples, customer database, that's PII, personally identifiable information, financial transactions, API authentication keys, intellectual property, like your source code, algorithms, user session data, admin credentials, and backup data. The next thing is to classify data. What's going public? Marketing materials, anyone can see that. Internal, employee directories, only for employees. Confidential, customer data, need to know only. Then restricted, payment card data, strict access controls. So when you do this, because if you don't know what you are protecting, you can't protect it effectively. The second question is, what could go wrong? Identify threats for each asset. Brainstorm, how could an attacker compromise it using the STRIDE framework? The STRIDE framework, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So spoofing, can someone impersonate a user? Tampering, can someone modify data? Repudiation, can someone deny their actions? Information disclosure, can someone see sensitive data? Denial of service, can someone make it unavailable? Elevation of privilege, can someone gain admin access? So that's STRIDE framework. So example of an S3 bucket threat, and I want to analyze the threats that can happen to an S3 bucket using the STRIDE framework. Spoofing, if I start with spoofing, maybe an S3 bucket with customer data. If I start with spoofing, I'll say an attacker can create buckets with similar name to trick users. That's spoofing. Tampering will be attacker can modify objects in buckets. Repudiation, attacker can delete logs to hide their access. Information disclosure, if bucket is public, data is leaked. Denial of service, attacker deletes all objects. Elevation of privilege, IAM role as S3 permissions, attacker can use SSRF, that's server side, to get server side request forgery to get role. So now the third question is, how can we prevent it? That's for you to define mitigation. For each threat, design security controls. Now let's use the S3 bucket again. If I want to mitigate, for example, information disclosure, I will enable the block all public access. I'll make sure that the bucket policy denies non-SSL access. I'll use SSE KMS encryption at rest. I'll use VPC endpoints, private access only. I'll use AWS config to detect public buckets. I'll automate remediation if made public. So if I want to also mitigate for tampering, that's modification of objects, I'll say, okay, versioning enabled, can recover previous versions. MFA delete, requires MFA to delete. Object lock, one for compliance. IAM policy allows read only for most users. So like that, you would, if for each threat, you would design security controls. So another one is how will we respond? That's incident response planning. So even with perfect controls, breaches can still happen. So how will you respond? Let's use the S3 bucket data breach again. So the response plan will be detection. How do we know? CloudTrail alerts. Unusual number of get object calls. The guard duties, maybe suspicious IP accessing S3. Then AWS notification, or AWS notifies us that bucket became public. So another one is immediate response under response plan. First 15 minutes, you block public access, you rotate credentials if compromised, you review CloudTrail logs to identify scope, and you isolate affected systems. So you do all this under how to respond. So having this plan before an incident makes response 10 times faster and more effective. So when to perform threat modeling? Ideal times to perform threat modeling is during design phase, before you write any code, before you deploy anything. If you're designing a new e-commerce platform, you should have a threat model, your user login flow, your payment processing, your database access, your admin panel. So you identify threats, you design mitigations, and you build them in from day one. What can really happen between a user logging in and a user trying to pay for something? What are the things that can happen? You identify the threats and you design mitigations for it, for each threat using the STRIDE framework. Then before another ideal time to do threat modeling is before major changes. If you're adding a new feature, or you're migrating to cloud, or you're integrating third-party service, you should actually what's it called? Do threat modeling, because the threat model has changed. Like whatever it is you're adding, there's a new threat model for that. So what new attack surface do we have for this new feature? What new data flows? What new permissions needed? Another time to do threat modeling is after security incident. If something goes wrong, what failed? How do we prevent recurrence? For example, again, if the bucket becomes public, you threat model, how did it happen? What controls failed? What additional controls do we need? How do we detect it faster next time? Then another time to do threat modeling is regular reviews. When you're doing maybe your quarterly or annual threat modeling for existing systems, because threats evolve, new attack techniques can emerge. So that's it. Like now, 10 years ago, server-side request forgery were not really known like that 10 years ago, but now they are very, very common. So benefits of threat modeling, proactive versus reactive. Without threat modeling, you build your system, you deploy to production, you get act, you respond to incidents, you fix vulnerabilities, you hope it doesn't happen again. But with threat modeling, you design your system, you identify threats, you build security controls alongside, you deploy securely, you monitor and maintain, and you have a much lower chance of breach, have cost savings, better security, you're able to comply, there's team alignment, and all of that. So do you have any questions before we move to Microsoft Threat Modeling tool? So what is the Microsoft Threat Modeling tool? Microsoft Threat Modeling tool is a free application from Microsoft that helps teams identify security threats during system design. So think of it as a security assistant that lets you draw your system architecture, automatically identifies potential threats, suggests mitigations, generate threat reports. So why did Microsoft create Microsoft threat modeling tool? Microsoft learned this lesson the hard way, actually. They learned this lesson so you won't have to. So in the early 2000s, Microsoft products had terrible security reputations. Like Windows had constant vulnerabilities. IIS web server was a favorite target. SQL Server had high-profile breaches. So in 2002, Bill Gates sent a memo. Trustworthy computing. Security is now the number one priority. So Microsoft developed security development lifecycle, that's SDL. So threat modeling became mandatory for all products. Every feature had to go through security review, and tools were created to scale this across the company. So the threat modeling tool was born from that initiative. So now Microsoft products are significantly more secure, and they've released the tool for free to help others. So some of the key features: you'll be able to create a data flow diagram. That's a visual way to map your system, has external entity, has process, has data store, has data flow, and it has trust boundary. Trust boundary is where security context changes. So let's see if we can quickly build something. Also, it will generate threats for you. It uses Strike framework automatically. So when it generates threats, you see the components and data flow. To ask from Stride to ask, can someone spoof identity here? Can data be tampered with? Can actions be repudiated? Can information be disclosed? Can this be denied? Can privileges be elevated? It will use auto-generated threats. Once you are done building or mapping your architecture, it will help you build. So this is what you do to have a structured workflow. You create the model, you draw architecture, you generate your threats, you review and prioritize threats, you define mitigations, you validate mitigation, you generate reports, and you share with your team. So this structure ensures nothing is missed and makes it easy to hand off to other teams. Okay. So attack simulation in cloud security. Attack simulation involves safely testing cloud defenses by imitating real-world attack techniques in a controlled environment. Examples of such simulations, like we did, anytime we do in the previous classes, anytime we do a small project, I would say, okay, let's test if this is working. Let's try to do something different from what we've done so we can see if what we enforced is actually working. So that is simulation. So testing access controls with restricted IAM users, checking if storage is publicly accessible, reviewing logs for suspicious login attempts. Simulation helps validate whether security controls are working as intended. So cloud threat identification is essential for proactive security, understanding common threats, applying the shared responsibility model, and using structured tools like the Microsoft Threat Modeling tool helps organizations detect weaknesses before attackers do. So in your free time, please design a simple cloud architecture diagram. Use threat modeling to identify at least 3 potential threats, suggest mitigation controls for each threat. So let's take maybe like 2 questions or so before we move to. So again, attack simulation is not acting into production systems without permission. It is not breaking things to see what happens. It is not testing in environments with real customer data, and it is not using tools you don't understand. It is ethical security testing with authorization, controlled experiments in test or dev environment, validating that security controls work as intended, and learning how attacks work to defend better. Keywords here: safely, testing, controlled. Attack simulation involves safely testing cloud defenses by imitating real-world attack techniques in a controlled environment. Please don't hack other people, please. So attack simulation is essentially purple teaming. You play both roles. You defend, you attack. Okay. Thought somebody was trying to talk. So do we have any question before we move to like the two?
Yeah, I have a question.
Paul, is that you?
Yeah, it's me. So, so this is more like practical day to day. So I know I was on TikTok some days ago and somebody sent me a link.
Okay.
And so what can you recommend? Because I was reading
Wait,
something.
sorry. Somebody sent you a link. Did they leave money behind for you?
No, this one didn't even leave money behind. I was discussing with somebody and he was telling me how this kind of attack that most times they send links that appear to be like WhatsApp links and links that they don't look suspicious. So I want to ask, is there like a site where we can take some links, copy some links and paste and
You are
check if they
curious,
are
I
really
mean,
genuine?
you want to shout, you want to know. You
No,
want
no,
to
I'm
know.
not curious. No, so this is how it happened, and it happened to my aunt, I think last year. So somebody sent her a link. That link was like all these like blog news. So once she clicked on it, they hacked her WhatsApp. So I was like looking this, like someone sent you like an Instagram link. Probably it has a particular preview video, and you say, okay, probably is something that you can learn or watch from. So is there like
Yeah.
are there like sites to protect ourselves? How we can check if this link is malicious or not, for us to
Yeah,
even
yeah.
know the likes of it.
Of
Yeah.
course, there are sites. You can use Virus Total.
Okay, that's total. Okay.
Or the other one, checkfish.ai.
Check fish. Okay.
That one is even specifically for checking phishing links. And sometimes you know that you can shorten links to make it look much more secure. So you can use there's this tool on shorten.it. So if the link has been shortened, you can unshorten it to see like the full version of the link.
Okay.
So you can review the actual destination of the link before you click on it.
Okay. Then my second question is, I observed something when you are creating like a resource on Azure, there is like a last part that talks about review and create, and most times it does a check before it eventually creates the resource. If you didn't configure some things well, it flags it. So on AWS, is there anything like that? Probably I'm creating something and I didn't do the right thing. So is there like a service that would flag that what you are doing is not compliant or is compliant? I don't know.
So for that Azure, review and create is probably when your configuration, maybe you pick the wrong, not that it will save you from misconfiguration. Maybe
Okay.
you're picking something, all these forms comes with conditional setting. If I give you a form and where there is email, you put probably your name or it doesn't look like the correct format that the form is expecting, it will flag it.
Okay.
Do you get? That's
Yeah.
what I review and create is for. It's not for like saving you from a breach or anything. So AWS has equivalents, but it's not like unified like that Azure. So review plus create. Do you understand?
Okay.
So review plus create is not really protecting you from if you make misconfiguration and it's correct, like what the form needs, the form can see it. Not like you are giving like a wrong format of what the form is expecting from you. You are giving a correct format of what the form is. It will actually go. So when it flags it, it means that that's not what the form was expecting. When I mean form, like where you have to fill your what's it called configurations. Do you get what I'm saying?
Yeah, I get you. Yeah.
So I don't
Okay.
want you to like confuse. I don't want you to think that review and creator will save me if I'm misconfiguring, if I'm doing something that will actually expose me to attackers. It will save you. It is because you were not entering what the form has been designed to, or the information that it was expecting you to give. Not even because you're wrong or anything. Like generally, you're not giving what it was expecting.
Okay. Okay. Thank you.
Okay. You see that number? I think there was a time that we were creating, we're typing something. It's in AWS. We're trying to create CS3, and it was returning us, was saying that no, you need to like it was giving us one red error that oh no, you need to like input something. Maybe like let's just say input validation. Do you get for like that's where that's how AWS works for it. So AWS might not have like review plus create, but AWS will like flag you before you even click on create. Like when you want to click on create, to flag you back and say, oh no, there's something that you have to add or something cannot be left empty or this is already exists. Do you get?
Yeah, I understand. Yeah.
Yeah. Do you have any other question? Sure. Okay. So maybe when you're practicing, you have to download your micro. It's actually not hard. Under 10 seconds, you download it. It's not something that will take long or anything when you're downloading. Under 10 seconds, you download your Microsoft Shrek modeling tool. So, not even sure if I saved what I was doing the other time. Let's create something very, very simple. Oh, no, no, no. No. Not this one, not this one. Go away. Create a model. So, click on create a model. So, what do you think we should do? What scenario do you think that we should do? I want to do something that will be very, 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 very fast so that because I'm actually feeling sleepy already. So, I want to think of a scenario. Let me think of a scenario. Scenario. Mm, mm, mm. Mm. Okay. I'm trying to like see if there's a scenario that we can use because it's very important for when you want to generate your church report or when it's generating church report for you. Depends on like it strictly depends on what you create. That's the thing. Strictly depends on what you create. I also don't want to create something that will take our time, so trying to look very, 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 very fast. Okay. She's back in like I don't know, but she just use templates. Okay. So let's say you're building e-commerce. Yeah, e-commerce platform where we would have external entities like user and the likes. Okay, let's do that. Let's see. So we're gonna build um an e-commerce app. We want to build an e-commerce app. And before we build the e-commerce app, we want to check where threats can come in, literally attack surfaces. So I'm going to start from external entities. And external entities are user. User represents external users, customers, and external system, third-party services. So let's do just that. So we're going to pick user here. Let me search for user. Where are you? Where are you? Where are you? Entity. Oh, where are you? Yeah, here. So let's just drag and drop here as user. Can name it user here. User. Or name it customer. This is just going to be very, very basic and fast because of time. So customer. Then process. What would okay, Elizabeth, you have a question?
Not really a question. Are you sharing? I don't know. I'm not seeing your
Oh, you're
screen.
not seeing my screen?
Yes, ma.
Oh my God. So hey, let me first stop sharing. Please let me stop sharing. Oh my God. So you guys have not been seeing my screen.
I don't know if maybe somebody else is seeing, but I'm not seeing your screen.
You guys didn't say anything. Oh my God. Wait, you guys have not been seeing my screen the whole time. Let me start from the beginning, please.
I can
Let me
see
just
now.
let me just click on new model. Let me click on new model. No, don't change. No, don't save, I beg. Don't save it. Ah. Oh God. No. So I said we want to build a web server, but we want to build an e-commerce app, and we want to like check how threats can come in. So I said we will first create external entity, an external entity users or external system that's third party. So I'm going to like drag and drop. Please next time you guys should not just say, you guys should not just keep quiet now. I thought you guys would see my screen this whole time. So drag and drop user here or anywhere literally. Then rename it to customer. Nothing much yet. Just leave it like that. Customer. Then add a process. What would customers do? The customer would use a web server, right? So let's go to process. General process right here. Web server. So just drag it here. So web server. Rename it. Rename that web server to e-commerce. Because we are building an e-commerce app. So e-commerce web app. Okay. Then data store, database. So let's add database. Database. So I saw it just now. Yeah, simple. Yeah. So let's rename this to customer database. Customer database. RDS. So another one for cloud storage. Cloud storage. It's gonna be very fast, so let me put it here because the e-commerce will communicate to the customer and to also communicate to like the cloud storage. So cloud storage is holding product images. That's the S3 buckets. Product images. Product images. Images. S3. Okay. Let me just put S3. Maybe we go S3 buckets just okay. So yeah. What else? I think that's all we need for now. That should suffice for now. let's add data flows, data flow between customer and the web app. A data flow between customers and the web app. So data flow somewhere around here. Oh, very, very looking for the story. It's I think rating something like something. Something like yeah, which is yes from what's it called? From customer to here to connect this and bring this so connect it. So that's we have HPS. So let's just username slash passwords. Username slash password. So then from web app to customer database, can just use let's just use a generic data flow. So generic data flow. So web app to customer database. That's
Sorry, I'm trying to access this tool. Where can I get it from?
oh, you should just search for Microsoft Threat Modeling, so you find it there. But I can send. Do you want to start doing it now? I can just send you the link. Maybe like later. I don't know. Do you want to do it now?
Yes, I'm currently trying to access it.
I'll have to like send
I
you.
just
Alright.
downloaded it. I sent the link.
Oh, thank you very. Oh, God bless you. God bless you. God bless you. All right. I'm trying to rush because I'm already feeling sleepy. Okay, so between web app and customer database, the data flow there will be SQL, that's app credentials. So SQL app credentials. Mhm. So now we take another data flow again. Web app and S3. Web app and S3. That's why I brought this one down first. So connect this and information is connected very well. So I'll name this I'm gonna name this S3 API. S3 API. IAM role. IAM role. So now let's add looking at this. Where do you think or where is the internet facing what's it called? Internet facing components. Where are the internet facing components? Can you hear me?
Is it the e-commerce web app?
Go on.
Yeah, I said the e-commerce web app is internet facing.
Okay. What else?
Um, the customer,
Okay.
yeah, I think the customer, yeah, because that's HTTPS. I would,
You want to say something?
So I wanted to say being able to pull images too. I think it should be form of internet space. I
So
don't
I
know.
can't hear you.
I said being able to pull product images.
Mm, okay. All right. Okay. So there are like two places. You guys were right. E-commerce is internet facing. Customer database to should draw. Although so that one is internal anyways. That one is internal. Customer database and S3, they are internal resources. But the web app, the customer and the web app, they're exposed to the internet. So that's an attack surface. But the database and S3 are not exposed to internet. You know, when you're setting it up in AWS, wonder what subnet would they be?
Private.
Private subnets. So that means they don't have access to the internet. But if your web app is compromised, the boundary can limit lateral movement. So let's start from the first one. We're going to draw boundary to around what's called customer and web app. Customer is untrusted. Anyone on the internet, everything crosses from hostile territory into your infrastructure. So that's our first line of defense. So let's come here. If I had known, I would have made this. Let me see. So maybe trying to see if just see there'll be enough space to draw the boundaries. Okay. So I'm able to draw the boundaries, yeah. Okay. Not first boundary. Yep. Yes, let me use this. Let me use this. Let me use this. So, what's the name this? I want to give this a name. So, I want to use the internet, untrusted. So what did I call the internal component? The database. So between the e-commerce web app and the RDS, our RDS and our instance and S3 internal resources. I'm trying to make sure that's what I'm trying to like, yeah. So between this, oh wow. So between this and this. So it covers both the S3 and this one should be trusted because they are internal. That one. So let's say VPC trusted. So let's generate threats. As I said, this is just going to be basic because of time. So let's generate threats. So can you see? Can everybody see my screen?
Yes.
Yeah.
Okay. So spoofing diagram one. So the two automatically would analyze our diagram. So the threads will appear here in the bottom panel, and each thread has an ID number, a title, category by stride, interaction, which component of flow. interaction, then severity, then severity, then status, not started, mitigated, like that, like that, like that. So for example, now this one, spoofing the customer external entity. The category is spoofing. And the interaction here is customer may be spoofed by an attacker, and this may lead to unauthorized access to e-commerce web app. Consider using a standard authentication mechanism to identify the external entity. That's the description. You can also add your own justification. Then the interaction here is through HTTPS, username and password. Then priority is I. Let's check another threat. You can see cross-site. Yeah, cross-site scripting, and the category is tampering. It means that the web server e-commerce web app could be a subject to a cross-site scripting attack because it does not sanitize untrusted inputs. The interaction again is HTTPS username password, and the priority is I. Let's check another threat. Elevation using elevation using impersonation. Elevation of privilege. E-commerce web app may be able to impersonate the context of customer in order to gain additional privilege. Same interaction, priority, still very high. Another one is spoofing of what is this? Yeah, spoofing of destination data store, product images, S3. Category spoofing. Product images S3 may be spoofed by an attacker, and this may lead to data being written to the attacker's target instead of product images S3. Consider using a standard authentication mechanism to identify the destination data store. Interaction, S3 API IAM role. Priority, high. And the last one here, potential excessive resource consumption for e-commerce web app or product images. Category, denial of service. Does e-commerce web app or product images take explicit steps to control resource consumption? Resource consumption attacks can be hard to deal with, and there are times that it makes sense to let the OS do the job. Be careful that your resource requests don't deadlock and that they do timeouts. Interaction, S3 API IAM role, priority, I. So when you click on a threat, you read the description, you decide, is this threat relevant to my system? Some threats may not apply. Then you decide again, what's the actual risk? How likely is this to be exploited? What's the impact if exploited? Then you update status. If it's not applicable, you update the status. You come here and say, not applicable. Or you come here and say, mitigated, depending on whatever you do. Or you come here and say, needs investigation. So not applicable means that if threat does not apply to your system, needs investigation means that you're unsure. Mitigated means that you've addressed it. Then you assign severity. Sometimes maybe some of them are not that what's it called? They're not that high. Maybe they're medium, maybe they're low. You assign priority or severity. So critical means if there's no critical, so let's start from I. I means serious risk, moderate difficulty, significant impact. Medium means moderate risk, harder to exploit or lower impact. Low means minor risk, difficult to exploit or minimal impact. Then another one is to define mitigation for each threat. When you select the threat, you expand mitigation section. Mitigation section. No. Where is mitigation section? Guys, let me to look for mitigation section because at this point, I don't even know. Maybe I'm the one who's sleeping or. Can you guys see mitigation section?
Yeah.
Where is it? Because I can't even say anything at this point. Where is it? Where is it? Where is it? Please show me. Show me, oh. I can't find it. Can you see it on my screen? Hello? Can you guys hear me? I don't know. Can I be heard? I don't know if it's my network. Hello? People want us to
Yeah.
sleep here. You are not talking.
We can hear you.
Yeah, audible.
You guys are not saying anything. I can't find mitigation section. I'm like, oh, you guys should help me. That maybe it's my eyes or because I'm sleeping already.
Is it not under status?
No, it's not. Oh, status is just for you to say, oh, you would investigate it, or you would, what's it called? Maybe it's not applicable to you or something. Okay. So, anyways, maybe there's no investigation in this part. Like, it's an investigation for you. What's the investigation for this thing? Sure. Spring first place. House probably that I'm not really sure. Anyways,
Can you try and right click on the thread? Maybe it's a option, don't know.
to try to see, I don't know why it's doing like that. Yeah, Marek is really showing where the threat is coming from, like on the diagram or something. Okay, sure. So normally when you select a threat and you choose your mitigation type, eliminate, mitigate, transfer, accept, maybe. So eliminate means that you want to redesign to remove the threat. Mitigate means that you want to reduce the likelihood or impact. Transfer means maybe insurance or cloud provider responsibility. Then accept is document as acceptable risk with justification. So you fill in your mitigation description, what you would do, who is responsible, when, and validation, how you're going to verify if it works. Then you add technical details in note section. This place should have been add. This is where you add note sections. Maybe you want to add like technical details. So example of mitigation would be maybe the threat is spoofing. Maybe for the customer external entity. Then mitigation type, you want to mitigate. Then description will be, okay, implement multi-factor authentication, username or password as first factor, SMS or authenticator app as second factor, store passwords hash with by bcrypt, implement account lockout after 5 failed attempts. So technical implementation will be, okay, use AWS Cognito for user management and MFA, configure your password policy. Remember, if you're doing 9 a.m., if you're creating 9 a.m. Accounts, you can do a password policy that their password must be 12 characters and some complexity requirement like special character and all of that. So then you should enable CloudTrail login for all authentication events, set up CloudWatch, and you can put somebody responsible. You can say Alice, security engineer, is in charge. Then you can say target date is probably at the end of third quarter. Validation will be you probably pen testing login, the login flow. Maybe you are attempting to brute force the account to actually check that, oh yes, this person is doing something or this person has done something. So the status can be in progress. Maybe you've configured your you configured your Cognito, but the MFA is still pending. So let me go back. Let me go back first. Maybe I'll be able to see. Let me keep on the short. Oh wait, I'm trying to see. There should actually be this thing for this. What I want to change. I want to change one of the threads to probably okay. Oh no, if I change it mitigated, I will not be able to see it again. No, 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 no. I think to mitigate it, I will not be able to see it again. This is not simplification. So, I have to check this again. I just have to should actually bring mitigation. Alright, so I'm bringing it. That list is already there. There's no longer mitigation. Maybe you just click on mitigation, but there should be. So some tips for effective threat modeling. Don't model the entire system at once. Break it into pieces. Like for example, now obviously an e-commerce web app is more than this. I think there should still be product database. There should still be product database. So should pick it one by one, should break it into pieces. Then focus on trust boundaries. Threats often occur at boundaries where your internet is, your network, unauthenticated, low privilege, your code. Then be specific. Generic threats get generic mitigations. So a bad threat is like, or a bad way to classify threats is just say unauthorized access. That's very generic. You get generic mitigation. But a good way is to say, oh, SQL injection in login form allows authentication bypass. So that would help you get a very, very good mitigation, not just generic mitigation. Another one is to think like an attacker. Always ask, if I wanted to steal data, where would I start? What's the easiest way in? What's the most valuable target? If I compromised component X, what could I reach from there? Then collaborate. Threat modeling works best as a team exercise. Developers understand the code, security knows the threat, architects see the big picture, operations know production environment. So everybody comes together and they're able to say, oh, okay, this is where, or these are the attack surfaces, then don't over mitigate. Not every threat needs expensive controls. Like risk is equal to likelihood times impact. So low likelihood, low impact threats, maybe just accept them. But high likelihood or high impact threats, definitely mitigate. Then always validate your mitigations. Don't assume controls work. Test them. Implement MFA. Try to bypass it. Encrypted data, try to access it without keys. Rate limiting, try to exceed it. So anything that you do, anything, any control that you enforce, try to simulate an attack to make sure that okay, what I actually did is working, or what I actually enforced is working. So that's literally it about threat modeling. Let me see if you can actually generate really, never mind. Never mind. Thank you very much. Let me see. Same thing. Let me try. Let's try. Let's see what happens. Not right next to what's. Yeah, there's mitigation. That's why I need to see. I don't know why there will be mitigation in the summary if we're able to mitigate anything. There will be the mitigation that we implemented there. I don't know why it's not there. Who else is doing it alongside? So maybe they can check their own. Paul, I thought you were downloading also.
My system is hanging. I don't know.
Okay. You know what? Maybe it's not the justification. Let's use justification. Let's use justification. What's this? What's this justification? Let me pick a threat. So for I'm trying to see. There was no threat that was showed up. So let's think together. Let us say we all worked on this together and we let's click on the threats. Is it not keeping? That's the issue now. But it looked like the justification for it or something. It's a request. Trying to bring out the Yeah. Why is not bringing out like the full. Oh God. Who's the
Yeah, I'm trying to search out how we can get the mitigation. So
I think it's
this
under
is saying
under justification. I think you put it under justification. So when you put
this
it
is
under
saying
justification,
okay, this is saying you should go under view, then analysis view.
okay. I don't. Oh God. Okay. Okay. View. Yeah, that is
Yeah.
how we got the threat. So we're already on analysis view as we have right now. We're on analysis view.
So it says click on any generated threat in the list, then including possible mitigation section. So that means it should be there automatically.
Yeah. Hmm. Where we are right now. And at first, I was able to like see the old property and everything. Now it's not even clicking. It's just showing me like the list. Like what's happening? But like I'm done anyways, but I just want to like really see. But your mitigation should be under justification then. Because when I created the full report, see, where's the report again? Here, when I created a full report on what we have currently, it was saying mitigation implemented zero. Then here, justification, no mitigation provided. So that means here, we're supposed to literally put our mitigation here. So after maybe if you're able to like find a mitigation, if you're able to write something in front of justification, that means you can now click the state as mitigated. Do you get?
Okay.
So if maybe for this one, putting the customer external entity, and I'm able to like justify that, oh, this is how we're going to like mitigate it if something like this tries to happen, then after that I will now come to state. There's a drop down and I'll click on mitigated, so it will automatically go to mitigate, like mitigation implemented. Maybe to add it to one or two, okay, you mitigated like 2 to 3 threats. But right now, everything that we have here is not started because we didn't click on anything. We only clicked on one. Because I was trying to show you guys how to like click on not applicable or probably click on missed investigation or probably click on mitigated. So in this full report, it's showing us like diagram, like each place where the threat is coming from. So for like this on that customer and web e-commerce web app, we have like about 3 threats for this alone. Then from e-commerce web app, between e-commerce web app and product images and S3 API IAM role, there's a particular okay, yeah. And S3 API IAM role, we have about 2 threats. Then under it again, between SQL app, SQL app credentials, we have about 3 threats. So that's what the full report does. It shows you exactly where the threats are coming from. So, still see, if I even save it properly, at least it should look like, should be away. So, the BA class first window. Save, save already. Threat model information. Yeah, threat model name. VA plus threat model. Oh, yeah, VA plus contributors, self security, maintains. You are in for high level system solution. I'll just say, let me put something there and I do. This is straight framework. Okay, investigation was provided. Not provided investigation, there is investigation was provided. This was provided. Assumptions. If I do anything, just like make a report for, let's do exam, but I'm so happens when one guy reports states to report reports report. Yeah. So can you see? Can you guys see my screen? Hello.
Yeah, I can see your screen.
So maybe when you want to do your project, you can just try to like model your thread first and see where thread can come in. But then contributors can put the name of your what's it called? People in your group. So yeah. So don't forget to put justification. So justification will serve as your mitigation. Do we have any question before we end the class? It's 10 already.
Yeah, thank you so much for the class. I just want to ask a very simple and straight question. We've been using AWS, all right? So, well, when we want to do this threat modeling, we went to download Microsoft threat modeling. This thing. Does AWS not have any tool like that?
A threat modeling tool.
Yes, that's right.
Well, sure. I'm not sure they do. I'm not sure they do. Well, you
So,
can definitely research, but I'm not sure they do.
okay. Because if they do, we'll have used it because we've been working on AWS in this
Yeah, and we have to
class.
use Microsoft.
Yeah, that's why I'm asking.
They don't have they don't have a threat modeling tool, a dedicated threat modeling tool like Microsoft. This is literally a tool that helps you drag and drop. They don't have an equivalent. They don't even have a stride. This one has like a stride framework incorporated. Like you don't have to start saying, oh, what's this? Is this spoofing? Is this tampering? This one has like the framework integrated. So when you draw your diagram, it just categorizes your thread for you. All you have to do is just probably like provide mitigation, and that's justification.
All right, thank you so much.
But well, I think they have threat composer, but it's not threat modeling. It's not as good as this. And it's not a visual diagram builder. It's text-based. So which one do you want to pick? It's also manual. To not automatically generate threads for you.
In
So
this
which one do you want
2020,
to pick? Which one do you want to pick?
in this 2026,
This one. Actually, you said you're
we
looking
can't
for
go
AW.
back.
Shebi, you said you
We
love
can't go back.
AWS. Oh God,
But that's how we've been
your
working
love
on
is
AWS.
fake. Your
No,
love,
it's not fake.
because it is not Microsoft's fault that AWS did not build something as good as this. You know, Microsoft had to go through like a very bad attack for them to be able to build this. If you were in
Wow.
class, I said they had to learn the hard way. Like when they first came out, all their products used to like face a lot of vulnerabilities, you know. So they're not like, okay, before we release any product, security is like number one. Now we need to go through every product needs to like go through that threat modeling. So that's why they have to like build this to help people, to help other, and they made it free. So if you want to use AWS Threat Composer, that means you'll be doing threat-based, you'll be doing text-based. Which one do you like? You don't like text-based. Okay, so do we have any other question? Hello? If we don't have any other question, I would like to call it a day. I wish everyone good luck in their upcoming project presentation. And I hope we've all been preparing for our project presentation. Just me, guys. How far? Who that you're working with, are they making things easier for you? Because that's another thing, yeah. You guys don't want to say anything. Okay, well, bye bye. Good night. You don't want to say anything. Bye bye. Good night. Good night, everybody. Let me stop sharing my screen. Please try out this during your free time. Try it out. Do your own simple stuff, like maybe just be your own personal scenario or something. Like you want to build an application and you know that this will involve this and this and this and this. You can just draw a very quick diagram. And it could just be this again. You might get absolutely different. It depends on, I mean, what I think is untrusted might not be what you think is untrusted. You might like have your trusted or untrusted boundaries in like many areas. So yeah, it will definitely generate like it might generate different results for you. So yeah. Bye everyone. Good night.
Thank you so much for your help.
So when I said you should gist me, you did not say anything. Okay, oh, good night, guys.